Hey everybody, welcome to Algebra 2 Practice Part 1. Here's what to expect. So we will be solving a list of problems in random order. The problems will involve fundamental Algebra 2 concepts. This will be a two-part series, and of course, feel free to pause the video and try the problems yourself. In fact, you should be doing that anyways, so I feel like I'm just not being strict by saying feel free. You have to pause the video. Anyways, first problem. Okay, this is probably one of our easier, the easier types of problems out of the problems we're doing today. This is more of an Algebra 1 type of problem, but I decided to include it just to warm us up. Okay, so if f of x equals to x squared and g of x equals to 3x minus 4, find g of f of 2. Okay, so pause the video. I want you to try to see if you can figure this one out. Okay, should be fairly basic. Just function notation. Okay, looking at what I did here. So I first wanted to work, inside out here. I first wanted to find f of 2, knowing that f of x equals to x squared, f of 2 should equal to 2 squared, so f of 2 equals to 4. Now we substitute 4 in for f of 2, and then we have to find g of f of 4. So then f of 4, remember we have f of x, f of 4 equals to 4 squared, so then f of 4 equals to 16. Now we have to find g of 16 because we plugged in 16 in for f4, we got g of 16. So then g of 16 equals to, well, remember g of x equals to 3x minus 4. So then g of 16 must equal to 3 times 16 minus 4. That should be 48 minus 4, which should be 44. So 44 is our answer. So answer choice B should be, or will, is correct. So it is correct. Okay, so if you got this one wrong, just look over your work here. This is sort of the standard way of doing it. So yeah. Okay, the next one here. Assuming that the curve does not touch the x-axis outside of the interval shown, which of the following statements cannot be true about this polynomial function? And the one thing I want to notice here, one thing I want to note here, is that when it says cannot be true, you just have to there is only one answer, and it is the false statement out of all of these. So these are all statements. Which one is false? That's what it's asking. Okay, so pause the video. I want you guys to try this one out. This one is one of the more trickier problems, which involves very key vocabulary. Okay. Okay. So I just sort of tested each of the statements. So has an even degree. So what is the definition of an even function? The function has to be symmetrical in respect to the y-axis, as we can see here. Uh, this function is symmetrical in respect to the y-axis. Multiplicity of x equals to 3. Well, as we see here, what it's referring to is this, oh, sorry, this 0 right here, even though it's not like it doesn't explicitly say 3 here, it's this one, because we see that this is the only point here, and 3 is a positive number. It's on the positive side of the x-axis. The only x-intercept on the positive side of the x-axis is here, so we assume that that's x equals to 3. It bounces when intersecting with the x-axis. What does that mean? So bouncing. So when we have an x-intercept, and it sort of looks like it's bouncing here, it's bouncing, that indicates that the um, multiplicity of that 0 is at least 2. A good example of that is if we have like, I'm going to try to draw on the side here, we have like y equals to like x minus 5 the whole squared. Okay, so thinking about this function here, at 5, the function will sort of bounce here, but technically, just sort of thinking about that, it will bounce, meaning that if you guys remember the fundamental theorem of algebra, which you will need to, or you should use for one of the problems here that are coming up, just understanding that we have a degree of 2, but technically it's one solution, and it's indicated by that bounce effect on the x-axis. Okay, so that's a true statement as well. 3, or C. a horizontal asymptote. So looking at this graph here, a horizontal asymptote cannot be established with this type of function. An example of a type of function that could have a horizontal asymptote or will have a horizontal asymptote, sorry, is the what color should I use? A rational function, or I'm going to erase this, but like a rational function. So like a function that, remember the rational function, like 1 over x, it has like a hyperbola, right? And that has a vertical asymptote at x equals to 0 and a horizontal asymptote at y equals to 0. Just gonna write that down, okay? So functions like that, and it's often determined by the domain and range, remember, asymptotes. You'll also see asymptotes in some of our trig functions as well. Okay, so also just understanding that this is not a rational function just because by the looks of it, really, is this a hyperbola at all? No. Okay, F. So this is a false statement, but so this is the correct answer, but I'm still going to test the other possibilities just because, process of elimination. I mean, for one of the problems, it does make sense to do process of elimination, but for this one, I still want you to understand the other answer choices and what it's asking. So f of 0 is negative. So thinking about f of 0 here, f of 0 implies that we plug in 0 in for x. So when we plug in 0 for x, we get our y-intercept. So thinking about this is this is 0, 0, and we have some point here. And our y value here, we don't know our x value. I'm just going to call this x here. But we know that um, this is our y here. We have a y value here, but our y value has to be less than 0 just because it's below 0, 0. So this is a true statement. So just understanding when we plug in 0 in for x, we get our y-intercept. And of course, when we plug in 0 in for y, that gives us the x-intercept. And the final one is it has a local maximum. Just thinking about local maximum and minimums here, I see one in quadrant 2, which is right here. About here is our local maximum. Doesn't give us the exact coordinate pair as to, but I guess we can't really determine that based off of the Cartesian plane that this problem gave us. But another one is in quadrant 4, and it is actually at our 0, uh, 3 comma 0. Now the reason why I was able to determine the exact coordinate pair for this one is just because it's saying x equals to 3 is a 0, and it has to be this one because that's the only 0 on the positive side of the x-axis. Okay, so yeah, this problem has a lot of just key vocabulary that can mess you up. And I understand if were having trouble with this one, but hopefully just understanding like what does multiplicity mean and the bounce effect, asymptotes. Um, I wasn't really fully explaining why we have asymptotes, but just talking about the domain and range function and why asymptotes are established. F of 0, hopefully you understand that. Maximum, local maximums, hopefully that as well. Even degree, hopefully you got that one as well. Just what these mean. Okay. Next problem here. What is the domain of this function? Square root of 2x plus 6 over x. Okay, so I want you to pause the video. I didn't tell you to, hopefully I told you to pause the video on the other one. Always pause the video and try the problem on your own. Okay, don't skip ahead and see what I'm writing or what I wrote. Okay, I want you to actually try the problems. Okay. Okay, so thinking about what we have to do first. So thinking about the properties, well, let's first look at our square root here in our numerator. We know that the square root just cannot be negative. Looking at just the properties of square root here, we are living in the world of real numbers in this specific problem because we're trying to find domain. So the square root cannot cannot be negative. Okay, so just understanding that our square root cannot be negative. In terms of the x in the denominator, we know that our denominator can just not equal to 0 because we cannot divide by 0. That will give us, that's undefined, right? So those are just our two conditions, or just looking at the properties of this specific function, the properties of square root and our denominator. Okay, so how do we find our domain? Well, we have to take the contents of what is inside the square root and put that greater than or equal to 0, because whatever is inside of there has to be greater than 0, but also it can equal 0 because 0 is neither positive or negative. So just square root cannot be negative, so we take 2x plus 6 greater than or equal to 0. Uh, oh, I can change the color of that. Cool. I'll go back to the boring gray though. So then remember 2x equals to, or 2x is greater than or equal to negative 6. Then x is greater than or equal to negative 3. So now what I did was I put it in set builder notation because all of the answer choices were in set builder notation, besides the all real numbers one, but just, we should put this in set builder notation because we know automatically this is not all real numbers. Now, I put it in set builder notation here. Now, one thing I'm going to add is not a lot of schools teach set builder notation. So if you don't know set builder notation, it is still really easy to understand, really easy to just use common sense here. Oh, which one has x is greater than or equal to negative 3? Which one has x cannot equal to 0? This one does. So just really, it's just common sense here if you don't know set builder notation. In this case, this is what it would look like. Okay, because all the answers were represented in set builder notation. So you don't know it. If you don't know set builder notation or what that even is, use common sense here. This has a part of our domain, and this one has part of the other part of our domain as well. So really just understanding like what is set builder notation, you doesn't really matter um, in the context of this problem because you can just see here x is greater than or equal to negative 3, x not equal to 0. Okay, so next problem. What is the slope of a line parallel to the line what is the slope of a line parallel to the line with the equation 5x minus 2y equals 100? This is also one of the easier, one of the easier types of problems that we're going to be covering today. It's more of an algebra 1 type problem, but okay, why not? We can include it. Okay, so pause the video, try this problem on your own. Okay, so if it is given that the lines are parallel, we don't need to know what this line is. But it's given that just two lines are parallel, the slopes must be the same. Okay, hopefully you remember that. If there are two lines and one line is perpendicular to the other line, then the slope will be the negative reciprocal. Okay, so hopefully you remember that. And in this case, the y-intercept is irrelevant here because we do have a y-intercept. Well, we do have like a y-intercept of some constant value here. That's really irrelevant because for it's asking for the slope. Okay, so the slope must be the same. So what can we do here? So it's giving us an equation here. So we can put it in either slope-intercept form or point-slope form to get our m value. I highly recommend slope-intercept form because point-slope form will take like forever. So here's what I did. I stop changing the color. Oh my, oh my God. Anyways, just thinking about this. I took our 5x minus 2y, equals to 100. I put it in the form y equals mx plus b. In fact, I'm just going to write here. Remember, y equals to mx plus b. Y equals to mx plus b. Of course, the point slope form is just y minus y1 equals to m times x minus x1. But don't use this one. I'm going to say just don't. Don't use point slope form. Use slope intercept form because it's really easy to convert this to slope intercept form. Anyways, took our 5x minus 2y equals 100. Try to isolate our y here. So we get negative 2y equals to negative 5x plus 100. y should, and then divide by -2 on both sides. We should get y equals to -5x plus 100 divided by -2. And then just understanding that we would get y equals to 5 over 2x minus 50. But since all the answers are in decimal, I put 5 over 2 to 2.5. So we get y equals to 2.5x minus 50. Remember how I talked about the the y-intercept is really unnecessary because you just have to look at the slope here. So m equals to 2.5 because it's in the form y equals to mx plus b, and we know that m is our slope. Our rise over run, our y2 minus y1 over x2 minus x1, whatever you want to think of it. So yeah, 2.5 is our slope of the line parallel and is also the slope of this problem. Or I mean, just think about, we find the slope of this, it's the same as the line parallel to this one. Okay, which of the following graphs best represents f of x equals to ax squared plus bx plus c, where a is less than 0 and b squared minus 4ac is less than 0? Think about this one. This one's a nice one. Okay, so think about it and pause the video. Do whatever you need to do, but pause the video and try it on your own. Okay, so thinking about this problem here, really, if a is less than 0, thinking about our extrema here, it has to be maximum. So we see here, our extrema is minimum on both of these, right? So now thinking about b squared minus 4ac, remember, x equals to negative b plus or minus the square root of b squared minus 4ac holding over 2a. That's our quadratic formula. It is implying that if this square root, whatever is inside this b squared minus 4ac, that's inside the square root, if that is less than 0, we will have no real solutions, meaning we won't have any x-intercepts. We will have complex solutions. Remember, remember imaginary numbers, that will be involved into our solution here. So thinking about this, we will have no x-intercepts, and our x-intercepts determine our real solutions. So in this case, we have, just gonna highlight some blue here. We have two x-intercepts here, so it cannot be this one. So D is the correct answer because it fulfills this criteria. Okay. So yeah, hopefully you got that one. It's just really testing your knowledge of quadratics and imaginary numbers, or just complex numbers. Okay, this one. Which of the following is a polynomial whose roots are 2i, negative 2i, and 5? Pause video. Do it. Okay, remember how we talked about the fundamental theorem of algebra? Use it in this problem. It can really, and I talked about process of elimination, how you should not really, in terms of like me teaching this, I should think of all the possibilities, but really, really, I don't want to come down to the point where I have to teach you how to do 2 plus 2. This is truly a fundamental theorem. Okay, there's also something called the fundamental theorem of calculus. It's not like this, but they're both. This is fundamental. Okay, this is fundamental. There are fundamental theorems and everything. So we can eliminate A, or we can eliminate B and C. Why? Because the fundamental theorem states that the degree of a certain function, like for this one, this is x to the first here. Degree is 2. Just gonna write that down. Hopefully you remember what a degree is. Degree is, or how to find the degree. You have to put it into standard form. Find degree. Anyways, degree is 1. These are in standard form. Just letting you know. So if degree is 2, degree is 1, and we're given 3 solutions, according to the fundamental theorem of algebra here, the degree determines the amount of real and complex solutions of a function. So we're given 3 total solutions, including complex solutions. So this will only have, right here, only, I don't need to write in all caps, only 2 solutions. Going to put 3 exclamation marks there. This will have only one solution. well, I'm gonna put like 4 exclamation marks there. Okay, so just understanding that we could easily eliminate them using the fundamental theorem of algebra because it's really fundamental, just like 2 plus 2 equals 4 is fundamental. Okay, um, thinking about what we have left here, we have B, C, or sorry, we have A, B, and E. Aid, or what, I don't know, A, D, and E. We have those left. Um, thinking about this, we have to first equate them to 0, because if we want to find the roots, we got to equate these polynomials to 0. We can't equate none of these to 0, though. But if, of course, we don't get these roots, then it's, of course, E. Now, thinking about this, I'm going to try A first. Okay, so look at the left side of the screen here. That's A. Um, x cubed minus 5x squared minus 4x plus 20. I equated that to 0. I did factor by grouping. I got x squared times x minus 5 minus 4 times x minus 5 equals 0. So I found the common factor there. And I got x squared minus 4 times x minus 5. And I used difference of two squares formula. So if you remember, a squared minus b squared equals to a plus b times a minus b, or the difference of two squares formula. So you apply it here. So, I mean, you don't have to, first of all, because using the zero product property, right? X squared minus 4, x squared equals 4, using the square, and just solving that certain factor here using the zero product property, using the square root method, you're fine, you're allowed to do that. So we can just put this x plus 2 times x minus 2 times x minus 5. Also, going back to the fundamental theorem of algebra here, we have to apply the zero product property here. We would get 3 solutions. Now, what do you notice here? We get x equals to negative 2, 2, and 5. The given solutions are 2i, negative 2i, and 5. These don't match the given solutions. So we have to, so A cannot be correct. So now we're just down to, look on the right side of the screen here, by the way, we're down to D and E. So looking at D, we have x cubed minus 5x squared plus 4x minus 20. I was able to do factor by grouping here. So I got x squared times x minus 5 plus 4 times x minus 5 equals 0. I got a common factor of x minus 5. I got x squared plus 4 times x minus 5 equals 0. So in this case, you cannot use difference of two squares because there's no sum. Well, difference, first of all, means two squares. Difference means subtraction. There's no such thing as a sum of two squares formula. That doesn't exist. And then, so now we just have x squared plus 4 times x minus 5 equals 0. We apply the zero product property here. So when we get x squared plus 4 equals 0, we get x squared minus 4, or x squared equals to negative 4. Now remember, I equals to the square root of negative 1. So using your knowledge of imaginary numbers, just complex numbers in general, x must equal to plus or minus 2i. And of course, we apply zero property here. X minus 5 equals 0. X must equal to 5. And these three solutions match these three solutions. So D should be correct. Okay. So this one was just, was a long problem, but that's why use fundamental theorem of algebra so you don't have to just waste your time with B and C. Of course, C is easy. X minus 5 equals to 0. X equals to 5. I mean, but of course, B, you have to use, quadratic formula. I mean, it's a lot of work if you just unnecessary waste of time. So use fundamental theorem of algebra because it's truly fundamental. It's as fundamental as 2 plus 2 equals 4. Okay. Now, this is a calculator problem. This is the only problem out of all the problems we're doing that requires a calculator. In terms of the calculator you just need a calculator that's able to evaluate logarithms. Even if it's just base 10 logarithm, that it can only evaluate log to the base 10. Of course, if you know the change of base formula, I mean, but if you don't, that's fine. You just need a calculator that can evaluate logarithms to the base 10. Also, just understanding that You don't need a graphing calculator. Don't use a graphing calculator in any of these problems. Also, what was I gonna say? Uh, just under. Oh yeah. If you don't have a calculator at all, Google is your best friend. Just type in log of whatever it is, and it will give you some answer. Okay, Google's been good for that nowadays. Uh, but don't use Google to search up this exact problem. No, just if you need to you evaluate the logarithm, or then use Google for that purpose only. Okay. Anyways, of the following, which of the best approximates the solution of the equation q to the power of 5,000 equals to 10 to the power of x? Okay. So pause the video. Try to do this. Okay. It's the only one that uses a calculator. Okay. What I did first was I took the 2 to the power of 5,000 equal to 10 to the power of x. I took the log of both sides so that our 10 could cancel, and we isolate our x. So then I got x equals to log of 2 to the power of 5,000. Now I use the properties of logarithms here. I put this 5,000. I I took the 5,000. I put it down here. You do not have to do this. I just for just efficiency, typing it into the calculator, I use the properties of logarithms just to bring this 5,000 down here. Do not have to, though. But you should still know that this is possible. These two mean the same things. Knowing that is important. Okay. So anyways, when you type that into your calculator or whatever you're inputting the logarithm or whatever you're using to evaluate it, you should get x approximately equals to 1,505.150. And that is answer choice B. Okay, hopefully that was straightforward. Just testing your knowledge on logs. Okay, this is another logarithm problem. Now, look up here. Don't use your calculator. Do not use your calculator. Don't be sneaky. Don't use the calculator. You don't need to use it. These are logs that you can easily do without a calculator, or evaluate without a calculator. So if q equals to log base 10 of 0.01, I'm just going to give you a hint here. Do not convert this to log of 0.01 because we know the common log is log base 10. If we put this to log of 0.01, that will actually not help you at all and will not do anything. And you'll just have to put it back to log base 10 of 0.01 unless you know automatically what it equals to. But in terms of how I'm doing it, explain, like if you're having trouble thinking this to the power of, or 10 to the power of what equals 0.01. Just gave you a hint there. Uh, just exponentiating it gave you another hint there. You know, don't put it, you should have your base when you're trying to exponentiate. Anyways, r equals to log base 3 of 1, and s equals to the natural log of e to the power 6. Ooh, natural log. Okay. So then find the sum of q, r, and s. Okay, so pause the video, try this problem, and I'm pausing ready. Okay, so thinking about, look on the left side of the screen here. We're going to first try to find q. So q equals to log base 10 of 0.01. I first just put the log base 10 of 0.01 equals to q, just to sort of visualize how we can exponentiate this. Using just our knowledge of logarithms, this is like a basic property of the logarithm. We can write it in exponential form to 10 to the power of q equals to 0.01. Now think about it. 10 to the power of what equals to 0.01? Well, 10 to the power of negative 2 equals to 0.01 because 10 to the power of negative 2 is the same as 1 over 10 to the power of 2, which is 1 over 100, which is the same as 0.01. So then q would have to equal to negative 2. Now thinking about r here, r equals to log base 3 of 1. Yeah, I'm just going to write it as log base 3 of 1 equals to r. 3, then we can exponentiate it. 3 to the power of r equals 1. R would in this case have to be 0 because 3 to the power of 0 equals 1. Anything to the power of 0 has to equal to 1. So r equals 0. Okay, this one, our natural log one, s equals to ln of e to the power of 6. Now, this was, remember we were talking about the one before. This problem here, how I use the property of logarithms to take this down here. you will need to actually, you will have to do it for this one. So s equals to 6 times the natural log of e is the same as the natural log of e to the power of 6. Now, what does the natural log of e equal to? Well, we know that the natural log of anything, like the natural log of x, that's the same as the logarithm to the base e to the power of x, right? Remember e, 2.72 approximately. Anyways, um, thinking about just log base e of e, and how e log base e of e would have to equal to 1 because we exponentiated e to the power 1 equals to e. So natural log of e equals 1. So now just plug that in. S equals to 6 times 1. S has to equal to 6. Now we have to find the sum of all of q, r, and s. So we would have to then get -2 plus 0 plus 6. And that would have to equal to 4. Now, don't use a calculator. I just showed you. This is really straightforward. Just using sort of your number sense here. Oh, 10 to the power what equals 0.01. 3 to the power what equals to 1. This one, just log, this, just, even if you just think of it like if you get ln of e ever in a problem, think of it like how you know log of 10 equals to 1. Or if we have log, like just think of this formula. If you just think about if the base and the of, I'm just gonna call it the of, the like log base x of x equals to 1, right? Because x power 1 equals to x, you know, just if these are the same, it has to be 1. Okay, so yeah. Um, okay, this one. If f of x equals to 4x minus 9, then what is the value of f inverse of x? Okay, pause the video and try the problem. Unpause when you are ready. Okay, so there are two ways, way one and way two. I said way one's the best way because it is really the best way. If you are on like a test or something, don't use way two or unless you really have no clue how to do this or you don't remember inverse functions. Just understanding that the inverse of a function, if you have f of x and we need to find f inverse of x, we have to switch the x and y values. But really, way one is what you should be doing. So let's look at way one then. Um, or they say first is the worst, second is the best. We're going to look at way two first because if you understand way two, you can get way one. So look at the right side of the screen here. So finding the inverse of the function. We're trying to find f inverse of x. So if we want to find f inverse of 4, we got to first find f inverse of x. So this will take more time. Keep in mind. So we first know that f of x equals to y. So we can rewrite this as y equals to 4x minus 9. Remember, inverse function means that the x and y values switch, also meaning that the domain and range switch, but that's not important in this type of problem. So we have to put this as x equals to 4y minus 9, and then isolate our y. So we get 4y equals to x plus 9, y equals to x plus 9 over 4. And we would have to rewrite this as f inverse of x equals to x plus 9 over 4, because by definition, the inverse function is when we switch the x and y values. So we get f inverse of x equals to x plus 9 over 4. Then to find f inverse of 4, we just plug in 4 in for x, and we get 4 plus 9 over 4, which is 13 over 4. Since all of our answers were in decimal, I put it to 3.25. 13 over 4 is 3.25. Don't you dare use a calculator for this, by the way. Because 13 over 4, think of 12 over 4. 12 over 4 is 3. Okay? Or think of it this way. 12 over 4 is 3. Then 0.25 times 4 is 1. Or think of it this way. Um, what 3 times, or sorry, yeah, 3 times 4 is 12. Then 0.25 times 4 is 1. 12 plus 1 is 13. Okay, anyways. Um, way one is really the best way. It's when you understand really that the inverse like is when the x and y switch. So you do have to understand that the x and y switch here, but just really understanding what that really means. So f inverse of 4 implies that y equals to 4. So we have to plug in 4 in for y in our f of x, because this in normal, if we had like f of 4, then we plug in 4 in for x. But if we have f inverse of 4, that means we plug in 4 in for y. So knowing that f of x equals to y, we would have 4 equals to 4x minus 9. 4x would equal to 13. X equals to 13 over 4. So that's 3.25. And of course, knowing that if x is 3.25, that's the same as f inverse of 4 equals to 3.25. Again, so now hopefully you understand that yes, this is a lot faster than this. But if you're really in a case where it's, better to have a the correct answer than not knowing how to do the problem at all, go with way two. But really do way one always if you get this type of problem. Okay, thank you guys for watching, and I'll see you guys in part two. All right, have a good night.